Welcome to part 1 of the Rob Roy vertical steam engine build. This engine began life after I visited a local steam fair and picked up a pair of steam cylinders which I believe to be from a Rob Roy steam locomotive. This has been partly completed, and although missing a few parts, it seems to be in reasonable condition, so I thought I would repurpose it and make a vertical stationary engine using this as the basis. To get a feel for the size and shape of the engine I wanted to build, I first mocked up this simple wooden model using scraps of timber I had in the workshop, and then began to work out the detail for the build. The two main support columns would be made from aluminium, so I drew these up and stuck a copy of the drawing onto a plywood board and cut out a template. This was then transferred to the aluminium with a pencil, and then I slowly cut out the shape of the support legs on the bandsaw. The second leg was also fabricated in the same manner. I wanted to machine the two columns simultaneously, so decided to clamp them together using superglue. One of the columns was clamped to a makeshift flat surface, with a sheet of drawing paper below to prevent it from sticking to the table, and the opposing column was then coated in glue and carefully brought together, trying not to glue my fingers together, and it was held for a few seconds until the glue had set. As you can see, the glue had gone through the paper and stuck to the plate below, but fortunately the paper prevented the majority of it sticking to the surface, and the two columns were now firmly joined. This was then taken to the milling machine, where all the rough sawn edges were cleaned up and squared, and the base of the feet were also milled to ensure that they would stand vertical on the base. The base itself was made from a 30mm slab of aluminium, and again squared off on the mill, but this time using a fly cutting tool. The base was blued up with marking fluid, and positional lines were scribed, along with holes drilled and tapped to suit the fixing screws for the columns, and also the axle support posts. The holes for the column screws were counterbored and fixed from the underside using M5 socket screws. The top of the support columns had a section milled out to allow the cylinder to locate accurately onto the uprights. To make the axle support posts, some more aluminium was sawn to size and again milled square, and this was marked out for the axle holes and clocked into position in the forge or chuck on the lathe. This time, as well as using superglue, I drilled and tapped two holes in the scrap areas of the material to use additional machine screws, as it was not fully secured in the chuck jaws and I wasn't confident with the glue holding this alone. The hole was then progressively drilled out and reamed to 14mm in readiness for the bearing bushes. A length of bronze bar was chucked, and this was faced and again drilled and reamed to suit the 10mm crank axle shaft. And then the outside was turned down to suit the reamed hole in the support posts, leaving it just a fraction oversized to ensure a good press fit into the supports later in the build. The final length was set and the bushings was cut to size using the rear tool post. As you see here, the bearing bushes will be inserted into the holes during later fabrication, using my vise as a press. The pair of axle supports, still fixed together, were then set in the mill, and a slot was milled on each side to create the toe for the support where the fixing screws will be located. This was then drilled out to the screw clearance size for mounting. They were then set at an angle in the bandsaw, and the excess material was sawn off, leaving room for it to be cleaned up on the mill. Here you can see the final milling of one of the supports and my big ugly noggin blocking the view from the camera. The crank began life as two 6mm discs, turned on the lathe and then reamed to accept the 10mm axle shaft, whilst held together with superglue. Here you can see the hole for the offset crank pin journal being drilled prior to reaming to 6mm. This was then blued and marked up with the use of a V-block, and a temporary pin was set in place to aid the setting up on the mill. A 2mm spacer was used to position the component in the vise, and the material was removed down to final dimension. The internal corner was left in situ, and with the use of a bull-nosed milling cutter, the internal radius was formed. This was then repeated on the other side, and then I used my torch to break the superglue bond. I'm not sure if I shot any footage of assembling the crank, but I certainly could not find it when it came to the edit. But basically, the two crank discs were set using a 10mm parallel as a spacer, and the main axle shaft and crank journal were gently tapped in and set with Loctite compound. When dry, holes were drilled and reamed for the locking pins, which were made from ground silver steel, inserted again with Loctite into the holes and hammered home for a permanent fit. I did find this footage, however, of the main axle being drilled in readiness for the same process of permanently pinning in place. The pins were then trimmed flush with the crank and cleaned up with a file, and a test fit with the bronze bearings was made. The next job was to remove a small section of the main axle that remained within the crank, and this was done by gently hacksawing it away, and then cleaning up any remaining metal with an end mill in the milling machine. Here now you can see that the crank is now clear. As you can see here, the angle of the posts was designed to echo the main uprights purely for aesthetic purposes when completed. The bronze bearings were pressed into the axle support posts off camera, with approximately 0.5 mm protruding inwards towards the crank on each side to create a clearance gap for the crank discs. And here I am assembling the components for a test fit, making sure to set the posts the correct way round, with help of centre dots created previously for reference. The screws were then fitted to attach the whole assembly onto the base. The next job was to build the eccentric strap, which started as a rough casting that I had bought previously. This was cleaned up and two M3 tapping holes were drilled in the shoulders. These were then tapped right through in preparation for reassembly once the strap was cut in half. The eccentric strap was then marked up and set in the mill and cut through in two operations using a 1mm slitting saw. Afterwards, one half of the strap had the holes opened up to the clearance size to accept the fixing screws, and it was reassembled, ready to be mounted in the lathe to turn the centre hole out to size. This was then carefully positioned in the 4-jaw chuck, and a boring bar was used to open the hole out to final dimension. To clean up the rough castings on the outside radius of the straps, a piece of aluminium was used to make a mandrel for the eccentric strap. This was turned just slightly oversize to allow the strap to be clamped tightly onto the mandrel. The whole chuck was then removed to maintain concentricity, and then fitted to the rotary table on the milling machine. The outside edges could now be milled to a high finish using a small end mill, And finally, the eccentric strap was placed in my mini vise for fine finishing with small hand files. A length of cold rolled steel was cut in the bandsaw to make the eccentric sheave and mounted in the lathe. This was then faced off and turned to final outside diameter to suit the eccentric strap. And then the bar was blued and marked out using one of my old digital calipers. And before anyone says, yes, I know, the Red Seal officer kicked me out of the tool room. The lathe was then put into back gear to prevent chattering when turning, and a custom ground high-speed steel tool bit was used to form the groove for the eccentric strap to be seated in. The first 10mm of the bar has also been turned down, and this is where the clamping grub screw will finally be placed. The eccentric strap was then test fitted until final dimension was achieved, and then cleaned up with Scotch-Brite for final checks. The strap is a nice fit on the sheave, without any noticeable lateral play, and rotates nicely within the groove. My parting blade was not long enough to cut off the component, so it was sawn off and returned to the lathe for facing, slowly working my way down to final size. Here the eccentric sheave has been cleaned up and deburred, and the strap rotates smoothly. This will, of course, require the offset hole to be drilled to mount this onto the crank axle, but I haven't yet worked out those sizes. My wooden model has a 5-inch flywheel, but I could only find a 4.5-inch cast iron flywheel available online, so this will have to do for now. The worst of the casting flashings have already been filed away, but I still need to turn and bore the flywheel in the lathe. So that will be in part 2 of this build video series. So that's about it for part 1, and there's still much more to make and do. I need to build a connecting rod to fit to the crank journal, some sort of crosshead and guideways, and of course a piston might be quite useful. And then there's the valve gear and the valve shaft coupling and the valve stem stuffing gland, the piston rod, the stuffing box and the crosshead shackle bolt, the valve stem head and the upper valve stem guide. Thanks for watching. See you in part 2.